Hello students, welcome to Breedmark Academy. Myself LS Nanda. Now in today's video, I am going to discuss the solution of a mathematics question that was asked in one of the shifts of JEE Main 2025 April session exam. This question is based on the topic of trigonometric equations. It says the number of solutions of the equation cos 2 theta into cos of theta by 2 plus cos of 5 theta by 2 equal to 2 into cos cube of 5 theta by 2 in closed interval minus pi by 2 to pi by 2 is. Now students, to solve this equation, first of all, I will write cos 2 theta into cos of theta by 2 as 1 upon 2 into 2 times cos 2 theta into cos of theta by 2, because I want to complete the trigonometric formula 2 cos A into cos B, which we know is equal to cos of A plus B plus cos of A minus B. And then we have plus cos 5 theta by 2 equal to 2 cos cube 5 theta by 2. Now students, this becomes 1 upon 2 into, just apply the trigonometric formula, it becomes cos of A plus B, which is cos of 5 theta by 2 plus cos A minus B, which is cos of 3 theta by 2. I am taking this angle as A and this angle as B. Now we have plus cos 5 theta by 2 equal to 2 cos cube 5 theta by 2. Now students, just collect the like terms. It becomes 3 upon 2 into cos of 5 theta by 2 plus 1 upon 2 into cos of 3 theta by 2 equal to 2 cos cube 5 theta by 2. Now students, in order to solve this equation further, just multiply the entire equation by 2. Now students, when we multiply both sides of the equation by 2, then the equation becomes 3 times cos of 5 theta by 2 plus cos of 3 theta by 2 equal to 4 times cos cube of 5 theta by 2. Now just take the term 3 into cos 5 theta by 2 onto the right hand side of the equation. So now the equation can be written as 4 times cos cube 5 theta by 2 minus 3 times cos 5 theta by 2 equal to cos of 3 theta by 2. Now students, you can clearly see the left hand side of the equation is taking the shape of an identity, and the identity is 4 cos cube A minus 3 cos A equal to cos of 3A. So that means now the equation can be written as cos of 3 times of 5 theta by 2, which is nothing but 15 theta by 2. So now the equation becomes cos of 15 theta by 2 equal to cos of 3 theta by 2. Now students, in order to solve this equation, either you can take cos 3 theta by 2 onto the left hand side of the equation and apply the identity cos C minus cos D, right? It becomes 2 sin C plus D by 2 into sin of D minus C by 2, and then you can solve it. And the another way is, if you treat 3 theta by 2 as alpha and 15 theta by 2 as theta and apply the direct formula for the solution of the equation cos theta equal to cos alpha, which is just theta equal to 2n pi plus minus alpha. You have to apply the general solution formula. And then you have to keep on putting different values of n so that your solution falls in the given interval. So now I am using the first method. Now it becomes cos of 15 theta by 2 minus cos of 3 theta by 2 equal to 0. Now it has taken the shape of an identity, cos c minus cos d equal to 2 sine c plus d by 2 into sine of d minus c by 2. You can also write this as minus 2 sine of c plus d by 2, that becomes 9 theta by 2, into sine of c minus d by 2, that becomes 6 theta by 2 or just 3 theta. Now students, from here we get either sine of 9 theta by 2 as 0, or we get sine 3 theta equal to 0. Right? Now we move further. Now students, I consider the equation sine 3 theta equal to 0. The general solution of this equation is 3 theta equal to n pi, where n is any integer. From here, I get theta equal to n pi upon 3. Now, since the given interval of theta is closed minus pi by 2 to pi by 2, so the allowed values of n are minus 1, 0 and 1. If you put any other value of n, then the value of theta will not fall in the given interval, right? So hence we get three solutions of this equation. The first one is 0 when I put n as 0. The second one is pi upon 3 when I put n as 1. And the third one is minus pi upon 3 when I put n as minus 1. Now students, I consider the equation sine 9 theta upon 2 equal to 0. The general solution of this equation is 9 theta upon 2 equal to m pi, where m is any integer. From here I get theta equal to 2 m pi divided upon 9. Now since the value of theta lies in closed minus pi by 2 to pi by 2, so the allowed values of m are minus 2, minus 1, 0, 1 and 2. So accordingly, we get the solutions as minus 4 pi upon 9, minus 2 pi upon 9, 0, 2 pi upon 9 and 4 pi upon 9. Now students, to find the final set of the solution, we have to take the union of both the sets. Now clearly 0 is coming in both the sets, so it will be counted just once. So hence this is the complete set of the solutions: 0, pi upon 3, minus pi upon 3, 2 pi upon 9, 4 pi upon 9, minus 2 pi upon 9 and minus 4 pi upon 9. So that means there are total 7 solutions, and hence option A is the correct one. Now students, I will post next question in tomorrow's video. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.